Hello students, good morning. Today we will discuss our class 12th NCERT mathematics chapter 11, that is 3-dimensional geometry, in which we are discussing miscellaneous exercise. Here we discuss 2-3 questions related to miscellaneous exercise. Here it is question 19. Find vector equation of line passing through 1, 2, 3 and parallel to the planes r dot I minus j plus 2k bracket closed is equal to 5 and r dot in bracket 3i plus j plus k bracket closed is equal to 6. These are the equations of the planes where the line is parallel to plane and line is passing through 1 to 3. We have to find the equation of the line. So, solution. Let the required line be parallel to vector B where vector B is equal to B1i plus B2j plus B3k. Equation of line parallel to B vector and passing through one, two, three, having position vector A is equal to 1i plus 2j plus 3k will be r vector is equal to I plus 2j a plus lambda b, that is a plus lambda b. So we may represent r is equal to a, that is I plus 2j plus 3k plus lambda into vector b is b1i plus b2j plus b3k. This is equation of line. Let us represent it by equation 1. Now, because line 1 is parallel to r dot I minus j plus 2k is equal to 5 and r dot 3i plus j plus k is equal to 6. Second, third. Therefore, because this line 1 is parallel to this, so in case of line and plane, dot product of this position, this direction cosine and this one will be equal to 0. Means normal to the plane, this is perpendicular to this. Normal to plane, these two planes is perpendicular to this one. That's why we may write as I minus j plus 2k dot b1I plus b2j plus b3k means normal to these planes is perpendicular to this line. That's why we may represent this product of these two is equal to 0. That is, lambda is taken common, 1b1 minus 1b2 plus 2b3 is equal to 0. It implies that it will be equal to 1b1 plus minus 1b2 plus 2b3 is equal to 0. And now product of this and this will be equal to 0. That is bi plus j plus k into lambda into b1I plus b2j plus b3k is equal to 0, which we may write in this manner: lambda b1 into 3, that is 3b1 plus 1b2 plus 1b3 is equal to 0. It implies that this lambda will become the denominator of RHS, so it will be 3b1 plus 1b2 plus 1b3 is equal to 0. Now we may solve these two equations and get the values of b1, b2 and b3, and then we have to put it in equation 1. So on further solution we will get one b1 minus 1b2 plus 2b3 is equal to 0. On solving this equation, 3b1 plus 1b2 plus 1b3 is equal to 0. So that is b1 upon minus 1 2 and 1 1 is equal to minus b2 1 3 and 2 1 is equal to b3 then 1 3 cross multiplication method minus 1 1. It implies that b1 upon minus 1 minus 2 is equal to b2 upon minus b2 upon 1 minus 6 is equal to b3 upon 1 plus 3. That is b1 upon minus 3 is equal to b2 upon 5. Minus b2 upon minus 5 means b2 upon 5, and that is equal to b3 upon 4. So from equation first, or on substituting in equation first, on putting in equation 1. One equation is this. We may put this value here. So the conclusion is R vector is equal to I plus 2j plus 3k plus lambda into minus 3i. These are the values of b1, b2, b3. So minus 3i plus 5j plus 4k. So this is only the required equation of line. So this question is now over. It is very important question. Now let us discuss question 20 of miscellaneous exercise of the same chapter. Find vector equation of line passing through 1, 2, minus 4 and perpendicular to lines x minus 8 upon 3. X minus 8 upon 3 is equal to y plus 19 upon minus 16 is equal to z minus 10 upon 7 and x minus 15 upon 3 is equal to y minus 29 upon 8 is equal to z minus 5 upon minus 5. So here in solution, let a required line be parallel to vector b that is b vector is equal to b1i plus b2j plus b3k. Now equation of line passing through 1, 2, minus 4 having position vector A vector is equal to 1i plus 2j minus 4k and parallel to vector b will be R is equal to A plus lambda b in same manner as we have done in question first. So, but here these are the lines, means line is perpendicular to line only. These are the Cartesian form of the lines. So R vector is equal to vector A is this 1i plus 2j minus 4k plus lambda into b1i plus b2j plus b3k. Let us represent it by equation 1. Because line 1 is perpendicular to lines x minus 8 upon 3 is equal to y plus 19 upon minus 16 is equal to z minus 10 upon 7 and x minus 15 upon 3 is equal to y minus 29 upon 8 is equal to z minus 5 upon minus 5. Therefore, means the product of these two, these are the direction cosines of these two lines. 3 minus 16 7 is the direction cosine of for line 1 and 3 8 minus 5 is for line 2, and it is perpendicular to this line which is vector whose vector equation is represented by equation 1. So that's why we may represent these equations by 3b1 minus 16 b2 minus 16 b2 plus 7 b3 is equal to 0, and 7 b1 plus 8 b2 minus 5 b3 is equal to 0. Or on solving this, it will become b1 upon minus 16 8 7 and minus 5 is equal to minus b2 upon 3 7 7 minus 5 in determinant form by cross multiplication method, and is equal to b3 upon 3 7 minus 16 8. It implies that b1 upon 16 5 is 80 minus into minus plus 80 minus 8 7 the 56 is equal to minus b2 upon 3 into minus 5 minus 15 and minus 7 7 the 41 is equal to b3 upon 3 into the 24 minus minus plus 16 into 7 and 16 7 the 112 here it is. So 24 plus 112. So now on doing further solution, we will get values of b1, b2 and b3. So b1 upon 10 minus 6 is 4, 7 minus 5 is 2, 24 is equal to b2 upon 5 9 14, 64 it is, and that is equal to b3 upon 4 2 6 213 136. Let us divide it by 4. So it will become b1 upon 6 is equal to b2 upon 4 on the 4, 4 6 the 24 is equal to b3 upon 4 3 the 12, 4 4 the 16. Again it may be divided by 2 also. So b1 upon 3 is equal to b2 upon 2 8 the 16 is equal to b3 upon 70. On putting in equation, So this is only the equation 1. Here we have to put the value of v1, v2 and v3 for getting vector equation of the line. So r vector is equal to 1i plus 2j minus 4k plus lambda into 3i plus 8j plus 17k. This is only a required equation of line. So this question is also now over. Now see the 21st question of the same exercise. Means that miscellaneous exercise of 3D. In solution, here question is prove that if a plane has the intercepts a, b, c and is at a distance p from origin, then 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon p square. This we have to prove. So in solution, let the equation of plane in intercept form according to question. X upon a plus y upon b plus z upon c is equal to 1. Now plane 1 is at distance p from origin O 0, 0, 0. Therefore, P is equal to 0 upon A plus 0 upon B plus 0 upon C minus 1 in mod upon root. Coefficient of x is 1 upon A, so 1 upon A whole square plus 1 upon B whole square plus 1 upon C whole square. So it will become, on squaring, P square is equal to 0 plus 0 plus 0 minus 1. Mod of minus 1 is positive 1. So 1 upon A square, because root is removed if we square both the sides. It is P square and it is 1 upon 1 upon A square plus 1 upon B square plus 1 upon C square. Now shift this denominator to LHS and this P square to RHS. So it will become 1 upon A square plus 1 upon B square plus 1 upon C square is equal to 1 upon P square. 1 upon P square. This only we have to prove. So hence proved. So this question is also now over. These three questions are very important. It is over.